everyone. In today's video, we are going to discuss about the confirmation analysis, and we are going to see what is the conformational isomerism. Okay, in the previous lecture, we have discussed the types of isomerization. We have discussed structural isomerism, and we have discussed all the types of structural isomerism. Then in the next lecture, we have discussed the stereo isomerism, and we have discussed the two types of stereo isomerism, which is what? Yes, configurational isomerism and conformational isomerism. So in the previous lecture we have discussed that what is the configurational isomerism and the two types of configurational isomerism, the geometrical isomerism and the optical isomerism are read. And now in this lecture we are going to discover the second type of stereo isomerism, and this type is about conformational isomerism. So first we are going to see the definition of conformational isomerism. That it is defined as that it is the type or it is the form of stereo isomerism. So that is really important. You always have to write a stereo isomerization here. You cannot write that it is a compound or it is a type of isomerism. No, you have to write it is a type of stereo isomerism. Okay, because conformational isomerism is under the type of stereoisomerism, not in the type of isomerism. Okay, so now which the isomers can be interconverted just by the free rotation about the singles bond. So what is going to happen, this it is a type of such stereoisomerism which is composed of what? A single bond. They don't have double or triple bonds between them, they just have single bond in them. So that is why they are interconvertible into each other. In the case of configurational isomerism, we have say that all the configuration isomerism is due to double bond. They are due to this double bond, and they are going to show your geometrical and optical isomerism. Okay, but now in the case of conformational isomerism, we just need a single bond between the carbon bond, and they show free rotations, mean the bond surrounded by these carbon atoms are just rotatable. They can show undergo the rotation, they can undergo the rotation, but this bond, due to double bond, they cannot rotate at all because there is a restriction. But in case of single bond, they just rotate freely. Okay, so therefore the conformational isomerism undergo the rotations, and this and they form a lot of rotamers or conformers okay, so the isomer form due to this isomerism is called as rotamers or conformers, and they are just different due to different arrangement in the 3D space. Now what is the energy requirements? The energy required for the free rotation is available at the room temperature. So all the energies which we are going to need are present at your room temperature, which is 25 degrees centigrade. So you just need a 25 degrees centigrade to perform this reaction, and there is no specific condition for the energy. Second thing is the number of isomerism. You know very well, due to this conversion a lot of isomers can be converted. So infinite numbers of isomers can be formed due to this isomerism, and the rotation is about the single bond, so there is no restriction and they can easily form. And every new isomer can be formed at every angle, mean some isomers are formed at 0 angle. Okay, some are formed at 1 degree, some form 2 degree, some form at 45 degree, 90 degrees, 60 degree. So a lot of angles and a lot of isomers can be formed by this. Okay, so this is the ethane, and they are showing that it is can undergo the free rotations of it. Now what is the conformers? Okay, conformers are actually show the compounds which are showing you conformational isomerism. They are called as conformers, and they are given a second name which is called as rotamers. Okay, rotamers, rotamers. Okay, so they can be called as rotamers and conformers. Confirmation analysis is just explained by the Newman's projection. So Newman's prediction is used to explain this confirmation analysis. So now we are going to discuss that what is this Newman's prediction. So Newman's prediction is nothing but it is just a convenient way to citing down a particular CC bond. So what is they are going to explain? They are saying you that Newman's prediction is nothing but it is a easy way to present the carbon carbon bond. Okay, so how we are going to represent it? We are represented by these two structures. First is this, second is this. So this is the structure of front carbon that we are going to represent. Front carbon by this structure and back carbon structure is this. So for example, in the case of ethane, you know very well that the ethane has two carbons and then it has hydrogen bonds with it. Okay, now how we are going to represent it? Okay, because we need a method, a simple method to represent this complex structure. Actually, you know very well that due to a lot of conformers can be formed, so we have to need a simple way to represent them. Okay, we cannot write the whole structure of a lot of conformers, so therefore we need a simple way to represent them. So the simple way is given by the Newman's projection, and it is this, that the first carbon of this ethane. Okay, I draw the structure of ethane here. Okay, so this is the first carbon, this is the second carbon. Okay, now I am drawing this first carbon. So the first carbon structure should be like this. So I have represented this carbon in this direction. Okay, these three lines, this dot, okay, this dot is going to represent your carbon, while the other three lines are going to represent your hydrogens. Okay, three hydrogens are going to attach with this carbon. Now there is the second carbon, which is this. Now we have to represent it. So how we are going to represent it? Now I am changing the color for you so that you can easily understand it. Okay, now I am drawing the second carbon below it, because this whole circle represents the carbon. This is the second carbon behind this first carbon, and now the hydrogen attachments with this carbon are like that. This is the one hydrogen, second hydrogen, and third hydrogen. Sorry for the bad writing, because to write up on the screen is very difficult, so you have to bear it. So if you have some confusion, then you ask in the comment section. I will take answer to you that what is this spelling and what is the word I am writing. Okay, so I hope you understand due to the two different colors. So this is the structure and this is the easiest way to represent it. Okay, so now you have seen that these carbons are just above and below each other. Okay, so the red color showing compound is the front carbon, which is looking at the front of you, and the second carbon is at the back. If I am drawing, if I tilt this projection, so it would be like this. First I am drawing the first carbon, which is represented by the red carbon or red color, so it is like this. Now I am drawing the second carbon, which is behind it. So I am going to tilt this compound and going to show to you. So after that, there is the second carbon atom and its hydrogen. So actually this is not the Newman's projection. The correct Newman's projection is this, but it is not. But I have just explained to you to explain how they are present. Okay, this is the front look and this is the back look. So I have just explained this concept to you, whether it has no concept for it. So now move on to the next page. So here you can see this form and this form. So this is another way to represent the Newman's projection. Actually what is going to happen when I draw the first structure of it, I have explained to you that first is there is like that. Now I am going to draw this first carbon. Sorry for that, and not. So now I'm going to draw the first carbon, so it is like that. Now I am going to draw this second form. Okay, so second carbon is behind it, which is showing by the blue color. Now just change in it this carbon hydrogen arrangement. So first I have drawn this arrangement. In this arrangement, what is going to happen, the angle between the two hydrogens is zero. Okay, two hydrogens or the two carbon is zero. But in the second form which I have drawn here, here the angle between the two carbon is 60 degree. So due to this 60 degree, and other type of form is present, and this form is called as staggered form. First form is called as eclipse form. So this is eclipse form, and this is the staggered form which I have drawn to you, and it has 60 degree angle in it. Okay, now we discuss some difference between this eclipse form and staggered form. So eclipse form is less stable. Okay, due to more repulsion, the hydrogens are very closer to each other, and they can show repulsion to each other, so it is less stable. So whenever there is repulsion, there is a less stability. And this concept, and this concept is really important. If you know this concept, then this lecture is going to be easy for you. Okay, so keep this concept in your mind, is that whenever the stability increases, energy decreases. So this is the concept you have to keep in the mind. If you want to learn the whole chapter, you have to keep this concept in your mind. So everywhere, in every topic, you repeat this concept. So keep this in your mind, that stability is inversely proportional to the energy. So every compound which is more stable always have less energy, or the compound which have high energy always be less stable. So if the eclipse form is less stable, so it means it has high energy, and the angle between the carbon hydrogen of the two carbon atom are is zero. Now in the staggered form, it is more stable, because the angle is stabilized itself, so it is more stable, and the minimum repulsion between them, because in the two hydrogen there is an angle, there is a distance. So due to the distance, there is a minimum repulsion. Now because they are more stable, so their energy is less, so they have less energy, and the angles between them could be 60-20, but in the stagger form it is always going to be 60. Now at the last, we have drawn the energy diagram. So what is going to be, if I draw this energy diagram on the paper, so you will easily observe that first in the x-axis and in the y-axis. Okay, in the y-axis I have take energy, and it could be potential energy. Okay, so you can simply write the energy. So here is the energy. Okay, and here is the angle theta. Theta could be 60, could be 0, could be 120, 360, 270, could be any angle. Okay, so now I have explained to you that there are two forms, eclipse and stagger form. So I have explained that eclipse form has high energy. So eclipse form, it could be like this at here part. Okay, because it has high energy, and the stagger form has less energy, so it could be here. Okay, so now what is going to happen, that first your eclipse form is going to form. Okay, after going to eclipse form, there is a stagger form. Stagger form will be formed due to the rotation. Okay, the first is eclipse form is going to form like that. This is the eclipse form. Whenever we come here, there is the staggered form, and stagger form is like this. I am going to explain to you, but the space is very minimum, so that I could not explain all of this concept to you. I hope that this is going to be visible for you. So now you have seen that due to this rotation, staggered form again, eclipse form, then we rotate for the 60 degree, again a staggered form is going to form. So this is the energy diagram which is going to show to you. So this is the simple form which is represented to you. Okay, so now we are seeing another type of isomer which is called as q isomers. So what are these q isomers? All the isomers except the staggered and eclipse form are called as q isomers. Okay, so you know very well, in the eclipse form 0 angle is present, in the staggered form 60 angle is present. But I have explained to you that 45 angle, 50 angle, all the angles other than 0 and 60, they could be present, okay, because conformers are infinite in number. So the isomer with 1 degree, with 2 degree, with 3 degree, with 95 degree, with 90 degree, all these isomers are present and they are forming a lot of isomers, okay. So accept this eclipse of Steger form, all the isomers are come under the term of what? Skew isomers. Now there is a atrope isomer. Atrope isomers, all the conformation isomers are impossible to separate except the atrope isomers. So they can be separatable, okay. So you can separate them, while all the compounds are not separate because of the little difference between them. So atrope isomers can be separatable. So they are separatable because of the high energy difference. So they have very high energy difference. So therefore they are separatable, and it will take 100 seconds. So we will have a time to separate them, okay. So the energy, actually they are going to explain the energy difference between them. Actually the energy difference between the isomers for the interconversion is 100 seconds. So due to this a lot of time, we can separate them before they are converting into one another, okay. So actually what is going to happen, these isomers are converting into each other, means it doesn't mean a stagger form will remain always a stagger form, okay. It could be changed into the eclipse form as explained in this energy diagram, that the eclipse form is going to rotate and convert it to stagger form. Stagger form again convert into eclipse form, okay. So they are not going to fix at one position, they are converting, just converting into one another cell. But in case of atrope isomers, actually what is going to happen, the energy difference between the two isomers is really great, okay. So due to this energy difference, we have a time of 100 seconds. So after these 100 second, isomer is can be converted into another type of isomer. So under this time, we have time to isolate one isomer out of it. So this is called an heteroisomer. I hope that you will understand this concept, that we have no time to separate these isomers because they are really going in the conversion into each other's cells. But we can separate heteroisomers because they have high energy difference, and due to high energy difference they take a lot of time of 100 seconds. And in this 100 second we can separate them, and due to this separability they are called as heteroisomers. Now next is the Sawhorse form. First I have represent a structure which is Newman's projection, which is a way to represent this conformational isomerism. Now there is another form by which you can represent your compound, okay, which is Sawhorse form. So what is going to include in it? So in the Sawhorse form, this is the eclipse form and this is again the staggered form, but they are represented in just a different way. So in this staggered form, actually this ethane molecule is explained, and in the 6 lane form, what is going to happen, this CC bond, okay, now you have to represent like this front carbon, now back carbon is again going to represent like this. So it is just a way to represent your molecule. Actually there is a lot of difficulty for the scientists to represent them, okay. So they have made a different projection, different forms to write up a molecule, a isomer, because you know that conformers are infinite in number. So scientists just find a way, a easiest way to write them, okay. So Sahor's form is another type of form by which you can easily represent it. So this is the eclipse form, okay. And the other form which now I am drawing is the staggered form. So first carbon is like this, now second carbon structure is like this. So again this concept is again repeated, that the eclipse form is less stable but have high energy in them. and less stable due to the bulky groups are on the same side. So in the eclipse group, bulky group are on the same side and there is a repulsion between it, but in the form of stagger, the bulky groups are at the maximum distance, so therefore they are more stable and have less energy. So now we are going to discuss the conformers of the butane in the next video. So that is enough for the today's lecture. I hope that you will enjoy this video. If you like this video, please share it with your friends, subscribe to my channel, and also press the bell icon to get the notification of all the videos which I have uploaded. So take care of yourself. मिलेंगे नेक्स्ट लेक्चर में, तब तक के लिए अल्लाह हाफिज़.